Hello and welcome to Spectacular Science, Up, Up and Away. This video is all about the science of flight and how it's possible because of Bernoulli's principle. So to start this one out, I'm going to ask for a volunteer. Good, I need a volunteer to do me some push-ups. Can you guys pop down and do a couple of push-ups for me? How many do you think you can do? Whoa, look at that. Easy, not even hard. Okay, hop up. Now it's my turn. I'm going to give it a go. Here we go. Oh man. You know what? I'm really bad at push-ups. I do not have as much pushing power as you guys, right? You guys can push a whole lot better than I can. You have more pushing power than I do. Did you know that the air is like that too? The air around us has pushing power. And in physics terms, we call that pressure. But you can think of it as pushing power. The air around you right now is pushing on your skin. You're so used to it, you don't even notice it. But it has pushing power just like you guys doing your push-ups do. And just like you doing your push-ups compared to me doing the push-ups, some air has more pushing power and some air has less pushing power. We call that Bernoulli's principle. Fast-moving air, show me a fast-moving hand. Fast. All right, air that's moving fast has less pushing power than air that's moving slowly. Okay, I'm going to explain it one more time and explain how this makes the flight of an airplane possible. And you want to pay attention because I have a quiz at the end of this discussion that involves this roll of toilet paper and a leaf blower. Okay, so you're going to want to pay attention. Airplane wings are designed like this. They've got a bigger curve on the top, more straight on the bottom. Because of that, air on the top has to move a lot faster to get all the way around. Versus air on the bottom, it can move more slowly to get to the back of the wing. So which air do you think is moving faster? The one that has further to go in the same amount of time or the one that has not as far to go?
That one. The one at the bottom.
This one's moving faster or slower?
Slower.
Slower, very good. And this, that has a further distance to go in the same time, that air is moving faster. Now remember, the fast-moving air has less pushing power. It doesn't push on the wing nearly as hard as the slow-moving air. So if I have air pushing on the top, but not that much, and air pushing on the bottom, but pushing a lot, what's going to happen to that wing? It's going to go up. The pushing power from the bottom pushes the wing up, lifts it into the sky, because it's got a greater pushing power, more pressure than the less pushing power fast-moving air. And that's how airplanes can fly. All because of that simple principle, that fast-moving air has less pushing power, and slow-moving air has more pushing power. Now, are you ready for your test? All right. I have here this roll of toilet paper. I'm going to have both of you be my helpers on this one. Can you hold this end and you hold that one? All right, now, I'm going to use this leaf blower. Do we have fast or slow air coming out of this?
Fast.
Fast. So it's going to have more or less pushing power? Less. Okay, less pushing power, faster air. Should I blow this in order to make this little roll of toilet paper have the toilet paper lift off into the sky? Should I blow it from the top or the bottom?
The top, I think.
Why the top?
Because it's moving. I don't know.
You don't know? Okay, that's all right. You're right. Because the fast-moving air has less pushing power, so then the air from the bottom will have more pushing power and will lift it up into the sky. Okay? Now, if you got it wrong, you could try it, because honestly, it seems like if I blow it from the bottom, that should work better, doesn't it? Because you're forcing air. Doesn't it seem like that would work better? Well, let's try it first and see what happens. Okay. I was able to push a little bit up from the force of the moving wind, right? The force of the moving air. But did it really lift off and take off?
No.
No, let's try it from the top now and see how it works with Bernoulli's principle. The fast-moving air over this top piece is going to cause lift because the slow-moving, higher pushing power air is going to push it up. Let's take a look. than pushing underneath, didn't it? Not what you really expected. I would have thought, until I knew about Bernoulli's principle, that pushing underneath would work better because you've got all this force. You're pushing it up. You're doing great. But it's got more pushing power if you get this fast moving air over the top, and that slow moving air, or holding still air even, will cause lift, will push it up and cause lift. You can actually do it yourselves. Now we have a few experiments. With this piece of paper, you can cause that same principle of lift. Once again, if I wanted this piece of paper to lift into the sky, I would think I'll blow underneath it and push it up, right? Kind of works. But if you blow over the top, you get it to go a lot higher. Let me show you here. Not as high, much higher. Again, the same principle. You want to give it a try? There you go, get right over the top of it. Blow hard, blow hard. There, you're starting to get it. All right, so you need to practice it a little bit in order to get it just right. Get right close to your lips. And blow right over top of it, onto the paper. There you go, blow onto the paper from the top. There you go. You need to practice it. You have to blow really hard to make it work. Okay, so really hard and right over the top. All right, I'll give you more time to practice it later. But as long as you have your lips right on the top and you're blowing really hard, you can actually get the paper to lift. Another fun one that's a little counterintuitive. I have this ping pong ball here and I wanted to pick it up with this funnel. The most obvious thing to do would be to suck on this end of the funnel and pull the ping pong up, which you can do, but kind of hard because it blocks your airway. And you can see why that works. You're kind of sucking it up into the funnel. But did you know it also works if you blow on the funnel? And this is, again, Bernoulli's principle. If I'm blowing really hard and fast, that fast moving air, less pushing power, the air outside will push the ping pong ball into the funnel. So I'll go ahead and show it. So I can get it to pick up. Do you want to give that one a try? Good. Blow super hard. Cool. You got it to hold for quite a while. You want to give it a try? Pretty cool. Now, the opposite is also true. Okay, so after pausing to wash the funnel, which is important if you know somebody is sick, you do this fun challenge. And I got a couple of adults on this one where I said, hey, I want to see how hard you can blow. So I'm going to give you this funnel with the ping pong ball in it, and I want you to blow the ping pong ball out. Like this, and you blow really hard, and nothing happens. And it's so funny to watch people because they're like, the first time they're like, huh, and nothing happens. So they blow harder and harder and harder. You want to give it a go? And they still can't get it to come out. Yeah, you tilted, you cheated. As long as you're holding it upright, again, Bernoulli's principle, that the fast-moving air has got less pushing power, so the pushing power from the still-moving air around the ping pong ball will hold it in place. So same principle, but two different ways to look at it, both by picking up the ping pong ball by blowing really hard into the funnel, and by trying to blow it out by holding it up like that. We have another fun ping pong ball one. And this one's really hard to see if you're not the one doing it, but I'll do my best. If you get it right and you blow right in between these two ping pong balls, what do you think they're going to do? What would you guess they would do?
Come together.
If you hadn't seen the experiment before, what would you think they would do?
Go apart.
Go apart, because that's what you said when I first asked you this a couple days ago. So you would think if I'm blowing between them, I'll push the ping pong balls out. But again, Bernoulli's principle, with that fast-moving air, there's less pushing power between them, and they actually pull together. Now you got to get right in between, and you have to have the right speed. So it might take a couple of tries and a couple of practices to get it right. So you could see it there. the one of them starting to move into the other. Let's try again. Oh, that one, not quite. If you blow right on a ping pong ball, then you just get the force of your air blowing it. Try it again. There, so you could kind of see how they curved in and then they went out when they got caught in the air current. So those are some fun experiments that really show Bernoulli's principle in action. We also have, just for fun, even though this doesn't really relate exactly to Bernoulli's principle, because paper airplanes don't really have the shaped wings, if you're doing a station or an experiment like this, you can always include some fun, different paper airplane guides. Just for fun, because it does show flight when you throw the paper airplanes, although it doesn't really directly relate to Bernoulli's principle, kind of more on air currents and things. It's still kind of fun, and it pulls you back to the idea that planes are able to fly because of Bernoulli's principle. Thank you for joining us.